Today we're going to be learning about prime factorization, and I just want you to take a second to look at, you should have a blank page in your notebook that says prime factorization at the top. If not, make a new blank page, say prime factorization at the top. Your first definition that you need to copy into your notes is prime. Prime numbers are numbers that have factors of 1 in itself. So, for example, 2 has factors of 1 and 2, and that's it. There are no other factors. There are no numbers that multiply to give us 2. Composite numbers are numbers that are not prime, and they have 3 or more factors. So, for example, the number 4, we could do 1 times 4, 1 in itself, to get 4, or we could do 2 times 2 to get 4. So the factors are 1, 2, and 4, and it has 3 or more factors, so it's a composite number. And so what I've done here is I've also listed the first 10 prime numbers for you: 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And if you need to take a second to pause the video and get this first part copied, I think that's an okay thing. I just wanted you to hear what I had to say first about definitions so that we can move to the next part. Today we're going to be working on factor trees, and so I'm just going to put a little picture here for factor trees. And we're going to start with factoring the number 36. And so the number 36 has factors. It has factors of 2 times 18. And when I get a prime number, I'm going to circle it and stop. So 2 is a prime number, so I'm going to circle it. 18 is not prime, so I'm going to break it up until I get prime numbers. I know that 18 can be found with 2 times 9. And so 2 again is prime, but 9 is not. I can break 9 up into more. So 9 actually can be broken down into 3 times 3. 3 and 3 are both prime numbers, so I'm going to circle them. Once I'm down to only prime numbers that I have circled, now I'm ready to write my prime factorization. So, for example, this is 2 times 2 times 3 times 3. I'm just writing all of my circle numbers with a multiplication symbol in between. And if I wanted to write this with exponents, which is best practice, we would say we have 2 2's, which means that's 2 to the 2nd power. And then we would multiply that by 2 3's is 3 to the 2nd power. Now, when we write this in factored form using exponents, it is important that our bases always be in order from least to greatest. So in this case, my first base is 2, my second base is 3. Those are in order from least to greatest. And we've got 2 squared times 3 squared as my final answer. This is factored form using exponents for the number 36. Now, some of you are probably wondering about what if we had broken up 36, there were other factors besides 2 and 18. What would happen had we done that? And I just want to show you a quick example of what if we had done that. And this isn't quite as neat of a copy, but I'll show you what I have here. I broke 36 up into 3 and 12, and then 12 wasn't prime, so I had to break that up into 2 and 6, and broke 6 into 2 and 3. And I still got 2 times 2 times 3 times 3. So I wrote my bases in order least to greatest, and then used exponents 2 to the 2nd times 3 to the 2nd. I also tried breaking 36 up into 4 and 9, and neither of those were prime, so I had to break them up. 4 broke into 2 and 2, 9 broke into 3 and 3, and still I got 2 squared times 3 squared. And I also tried breaking it up into 6 and 6, and 6 broke down into prime numbers 2 and 3 and 2 and 3. So I had 2 times 2 times 3 times 3, which is 2 squared times 3 squared. So no matter how I broke it up, at the end, when I got to my prime numbers, I still always had the same answer: 2 squared times 3 squared, 2 squared times 3 squared, 2 squared times 3 squared. and 2 squared times 3 squared. So it doesn't matter what factors you choose to start, as long as you work until you get a prime number and you circle that prime number is when we're going to find that prime factorization.